Okay, inverse of a matrix. Inverse of a matrix. I faced a question on this while I went to an interview in IISc Bangalore. See, they asked me a question, what is inverse of a matrix? Finally, I tell you, I laughed. See, what is inverse of a matrix? A square matrix of order n is invertible if there exists a square matrix B of the same order such that AB equal to IN equal to BA, where IN is unit matrix with n by n. So we can say that the inverse of A is B, that is A inverse is B. A inverse whole inverse is A, because A of A into A inverse is I, that is A inverse A. That is A is the inverse of A inverse, that is A inverse whole inverse. Okay, now find the inverse of the matrix. Find the inverse of find the inverse of the matrix A, B, C, D. Here, for finding inverse of a matrix, this is a method. A inverse is 1 by det A adjoint A. See, how do you get this? A of adjoint A becomes determinant of IN. You can prove this, or adjoint A of A. You can prove this. Now, keep this side 1 by A into 1 by determinant A adjoint A equal to IN. This can also be written as 1 by A determinant adjoint A of A, this side. Now, A inverse, because if you multiply on both sides A inverse, then you'll get 1 by determinant of A adjoint A. Now we see the inverse of a matrix A, B, C, D. A inverse is determinant of A is AD minus BC. AD minus BC of adjoint of this. So interchange this and change the sign of D minus B minus C A. This is the inverse of a given matrix. Now can you find the inverse of a matrix of 8, 4, 2, 9. A inverse is 1 by AD minus BC. 72 minus 8, 9 minus 4 minus 2, 8. This becomes C 64, 9 minus 4 minus 2, 8. This becomes 9 by 64 minus by 64 minus 24 by 64 minus 2 by 64, 8 by 64. This is the matrix of inverse of A. This way you can execute the inverse of a matrix. Now we see one more. Let A equal to cos alpha minus sin alpha 0, sin alpha cos alpha 0, 0, 0, 1. He asked me to find the adjoint A and verify that A of adjoint A is equal to adjoint A, determinant of A, I3, that is 3 by 3 I matrix. Let us find now C11. See, for finding C11, this is minus 1 power 1 plus 1 cos alpha 0, 0, 1. C12, this becomes cos alpha minus 1 power 1 plus 2 sin alpha 0, 0, 1. This becomes sin alpha. C13 minus 1 power 1 plus 3 sin alpha cos alpha 0, 0 becomes 0. So like that, C21 minus 1 power 2 plus 1 minus sin alpha 0, 0, 1 becomes sin alpha. C22 minus 1 power 2 plus 2 of cos alpha 0, 0, 1. This is cos alpha. C23 minus 1 power 2 plus 3 of cos alpha minus sin alpha 0, 0 becomes 0 because this into this is minus this into this. 31 minus 1 power 3 plus 1 of minus sin alpha 0 cos alpha 0 becomes 0. C32 minus 1 power 3 plus 2 cos alpha 0 sin alpha 0 becomes 0. C33 minus 1 power 3 plus 3 of cos alpha minus sin alpha cos alpha. This is cos square alpha plus sin square alpha is 1. Now adjoint of that one is, write it, C11, C12 is minus sin alpha 0, sin alpha cos alpha 0, 0, 0, 1 transpose. This becomes cos alpha minus sin alpha 0, sin alpha cos alpha 0, 0, 0, 1. This is adjoint A. Now determinant of A is A11 C11 plus A12 C12 plus C13, sorry, A13 C13 becomes cos alpha into cos alpha, this one, yeah, this is C1 plus A12 minus sin alpha minus sin alpha plus A13 C13. C13 becomes 0. This is cos square alpha plus sin square alpha is 1. Determinant of that is 1. Now A into adjoint A becomes A is what? Cos alpha minus sin alpha 0. Sin alpha cos alpha 0 0 0 1. Adjoint A cos alpha sin alpha 0 minus sin alpha cos alpha 0 0 0 1. If you multiply this, you will get cos square alpha plus sin square alpha. See, now if you multiply this, then you will get sin alpha cos alpha minus cos alpha sin alpha 0, like that. Cos alpha sin alpha minus sin alpha cos alpha, sin square alpha plus cos square alpha, this one 0 0 0 1 becomes I. That is adjoint A is determinant of A into I, because determinant of A is 1 or I 1 1 1. Yes. So next is adjoint A into A is also become I. So we can hence we prove that adjoint A equal to adjoint A equal to determinant of A into I. Okay.